Can one person have multiple passports? Or can one passport belongs to multiple people? The answer lies in the concept called cardinality. In this video, we'll introduce you to this concept and cover the simplest kind of cardinality, which is a one-to-one relationship. Cardinality is an important characteristic of a relationship between two entities, describing the number of instances of one entity that can be associated with a single instance of another entity via the relationship. In case if you feel lost about the terminologies, an entity is essentially the same as a table. An entity is a conceptual idea of a real-world object or concept. A table is the implementation of an entity in a database. An instance is essentially the same as a row. An instance is a conceptual idea. When being implemented, it will be a row in its corresponding table. To complete your ER diagram, you need to analyze the information you have collected from the requirement gathering phase, identify the cardinality of each relationship, and update the draft diagram accordingly. For example, without cardinalities, your ER diagram in its early stages may look like this. There are two things we need to explain on cardinalities, including direction and representation. Let's start with an example. Think about the database of a banking system. There are two entities representing users and accounts. So you have user and account as the two different entities, and their relationship can be broken down to two directional relationships, summarized using two sentences as is shown here on the screen. Sentence 1 says that a user has 0, 1, or more accounts. Sentence 2 says that an account is associated with one and only one user. Sentence 1 and sentence 2 represent two different directional relationships between user and account. In sentence 1, the direction flows from user to account. In sentence 2, the direction flows from account to user. In short, a sentence that describes a directional relationship from one entity to another has a subject, verb, and object. The direction always flows from the subject to the object. Now you know what direction means, let's talk about the representation. Given a directional relationship from entity A to entity B, cardinality describes how many instances of B which a single instance of A can and has to be associated with. Cardinality is represented by two graphical symbols on the relationship line between A and B. The symbols are used in pairs to represent the cardinalities. The symbol on the inner side represents the minimum instance number of B that a single instance of A needs to be associated with. We call that the minimum cardinality. The symbol on the outer side represents the maximum instance number of B that a single instance of A can be associated with. We call that the maximum cardinality. Both symbols are placed closer to entity B. See, the direction goes from A to B. Yet the two symbols need to be placed closer to B. That's something you want to pay attention to. Just so you know, you can swap the positions of entities A and B, and that will lead to the positions of min and max cardinalities swapped as well. As you can see, when the direction flows from A to B, the two symbols as a combination are always placed closer to B. Individually, the min cardinality is the symbol that's placed closer to A relatively, while the maximum cardinality is always placed closer to B relatively. Beyond that, you saw some symbols on the screen that requires explanation. The individual symbols, like a bar or a crossfoot, all represent quantities. So quantity 0 is represented by a circle. 1 is represented by a bar, and many is represented by the symbol that looks like a crossfoot. In the example on the left side, the main cardinality of the relationship from A to B is 1, and the max cardinality is many. Now you know the basics about the cardinality. We can revisit the example that you saw earlier. The relationship between user and account entities in the database of a banking system. The relationship between the two entities is summarized as two different directional relationships. On one hand, a user has 0, 1, or many accounts. On the other hand, an account is associated with one and only one user. The first sentence defines the relationship from user to account. Since a user can be associated with as few as 0 and as many as unlimited number of accounts, you can tell that the mean cardinality is 0 and the max cardinality is many. The second sentence defines the relationship from account to user. Since an account is associated with as few as 1 and as many as one user, both the mean and max cardinalities from account to user are 1s. In the end, you are supposed to merge the two directional relationships as one relationship between user and account entities. After the merge, the positions of the two mean and max cardinalities of the two directional relationships would be exactly the same as if you draw them separately. As you can see here from the representation on the screen, the max cardinalities are more closer to the entities. In comparison, the mean cardinalities stay further from the two entities. That's everything about the two aspects of cardinality, the direction and the representation. With such knowledge, we can put all the relationships you will see in the future into 3 baskets based on their cardinalities, including one-to-one relationships, one-to-many relationships, and many-to-many relationships. Such a classification is all based on the max cardinalities. We will look closely at the one-to-one relationships in this video. In a one-to-one relationship, each instance, or say each row in one entity, is related up to one instance, or say one row in the other entity. One-to-one, I mean the two ones here, refer primarily to the max cardinalities of both directional relationships. The mean cardinalities could either be 0 or 1. Generally speaking, one-to-one relationships are rare. But let's see at least one example to make sure that we're on the same page in terms of this relationship. Imagine that you are working towards designing a database for an online store named the Sci-Fi Collective, and have identified two entities, user and user address. The extracted relationship between the two entities can be summarized as following. A user may not have an address when they first register an account, but a user must have one and only one address before making a purchase. An address is associated with only a single user. Let's go from here and develop the two directional relationships one after another. So a user may have 0 to 1 address. Based on this, we can develop the directional relationship from user to user address. The mean cardinality is 0 and max cardinality is 1. So you can add the two symbols accordingly. Since the direction goes from user to user address, both symbols should be placed closer to user address entity. In contrast, an address is only associated with a single user, which means that both the mean and max cardinalities are 1. The relationship goes from user address to user, so you will place a pair of two bars closer to user. After that, you will merge the two directional relationships into one. This step is relatively easy to do because all the cardinality symbols stay where they are in the directional relationship representation. They just share the same line between user and user address entities. In case if you think we are finished here, we aren't. There is one more step, which is to restore the representations of entities. So far, we have used a simplified representation of the user and user address entities because we didn't list their attributes. We need to do so in a fully developed ER diagram. As you do that, you also need to place a foreign key in one of the two entities. And that's the only way for the entities to know that they are in a relationship when they are implemented as tables. In a one-to-one relationship, the foreign key is placed in the entity that's close to where the zero main cardinality is. You may also see other sources call this entity the optional site, and the entity close to the main cardinality of 1 as the required site. The foreign key is always placed in the optional site. This choice supports the data entry order and makes sure that you won't end up with a null value for the foreign key. If you ever try to place the foreign key in the required site, its value will need to be null from time to time, because a user is not necessarily associated with any addresses, especially those users who just register new accounts. In other words, when you follow the order of data entry to add a new user first, there is no existing address ID value that can be referenced at all. Null values can create unnecessary problems for your database. As a result, you should always place the foreign key in the optional site. However, as curious as you are, you may wonder what if both main cardinalities of the two directional relationships are zeros or ones, and what should you do in those cases? If both main cardinalities are zeros, both sides are optional, and you can place the foreign key in either of the two entities, like this, what you see here on the screen, or this. It's worth noting that when you have such a relationship, the foreign key values have to be null from time to time. As you can see from this example, a user is not necessarily associated with an address, and an address is not necessarily associated with a user. If you have such a relationship, you need to be prepared to deal with null values. That's when both main cardinalities are 0. What about when both main cardinalities are 1s? Well, two main cardinalities as 1s are good theoretically, but not in practice. If you ever have a one-to-one relationship whose main cardinalities are both 1s, you need to relax one of them from 1 to 0 for the sake of implementation. Let's use an example to demonstrate this point. Think about the relationship between two entities, department and manager. A department has one and only one manager, while a manager works for one and only one department. This is a classical one-to-one relationship. Both the max and min cardinalities of both directional relationships are 1. This representation is theoretically solid, but impossible to implement. When it comes to data entry, which table should you start with? A department? A department needs to be associated with an existing manager, or manager. A manager needs to be associated with an existing department. In other words, this design asks you to essentially place foreign keys in both sites, or say both tables. Such a design is impossible for data entry. If you enter a row into the department table first, there won't be any manager ID values that you can reference. The foreign key constraint that you put in place will cause SQL to complain and reject the data entry. If you switch the order of data entry and try to enter a manager information first, you will face the same problem. To avoid such an issue, you can relax one of the two main cardinalities from 1 to 0 to make implementation possible. For example, you can modify the relationship between department and manager like this. The first sentence will be revised from a department has one and only one manager to a department has 0 or 1 manager. Based on the revision, you can relax the main cardinality from department to manager from 1 to 0. After that, you have an optional site again. and you can place a foreign key in the optional side. If the two tables are ever represented in an ER diagram, the proper representation will look like this. That's everything about the one-to-one relationship. In this video, we covered the basics of cardinality and explored one-to-one relationships. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.